Hi, I'm Chet Haas, an engineer on the Android team at Google. So I did a DevBytes recently talking about anticipation and overshoot, principles from cartoon animation that could be applied to some user interfaces as well. We also talked about this in our Google I/O talk called The Moving Experience. You may want to check that out for more information on some of these principles, but I wanted to go a little bit further into these principles of anticipation and overshoot today in a different demo. So let's take a look. So as I click on the button, you'll notice a couple of things. One is that it reacts to my press itself, and then as I let go of the button, then it springs over to the other side of the screen. So press sort of skews over to the left, and then shoots over to the right, and then wobbles a bit to settle down into place. So that's the demo. Pretty awesome. Let's take a look at the code. So first of all, we want to figure out how to actually draw something like this. There is no skew property, there is no wobble and wiggle property on a view. So we need to do this manually by altering the canvas of a view. So you don't typically override draw, and if you do, very important, you have to call super.draw because we do things internally that track flags and state that you should not skip. Okay, having said that, it's okay to override draw, and in some cases you have to. In particular, in this case, I want to change the way the view is actually drawn, so I need to alter the canvas that it's drawn with. So the way you do that is by overriding draw and then altering the canvas and passing that up to the superclass. So when there is this skew value, which is going to be animated or changed between 0 and 1, then we're going to change the canvas itself. We're going to translate around here, which is basically we're going to set the right center around which we're actually do the skew. Then we're going to skew the object to sort of give it this shifted to the right or the left look. And then we're going to call super.draw and just say, okay, now draw your button. Now that I've completely mucked with your canvas, go ahead and draw. Meanwhile, here's how one of the animations works. So run press anim gets called when we actually press down on the button, and that works by using an object animator, which is going to animate this property called SkewX on this object. So I've defined a property setter called setSkewX, and I can use an object animator to animate that arbitrary property on my object. And I'm going to animate it between 0.5 and negative 0.5. And I'm going to set a particular duration for that thing. And so it's going to be awfully long as it rears back. And this is the anticipation element of this animation, is that it's going to rear back before moving forward. You can think of this button as one of those old cartoon characters. It's going to run forward, but before they do that, they're going to rear back so that they get all positioned and ready to do it. That's effectively what I wanted the button to do here. And then I'm going to set an interpolator so it starts very fast. I'm going to click on the button. It's going to quickly start into the animation and then slow down as it gets to the end, sort of giving that tension feel as it gets to its extreme point. And then we start the animation. If we look at the motion handler, so I handle touch events directly here because I want to know when I'm inside and outside the button so that I can disable the animation if they unclick when it's outside, all that stuff. And I also wanted to handle the perform press operation, and I want to handle the up animation. So when they've actually pressed, then we perform our click animation, and the click animation is going to animate across the screen, and then it's going to animate the skew to the other side. This is an overshoot element where I want it to stop suddenly, but if it's an organic element like this sort of skewy, squishy button that I've defined, then all of it can't stop at the same time because that's very unnatural. Instead, you're going to stop the button and then part of it's going to carry on because that's what gravity and inertia and motion does to our bodies, right? So the bottom of it's going to stop and the top is going to carry on, and then it's going to wiggle back and forth, so it's going to overshoot back to its original starting location and then eventually look like a normal button. So if we take a look at the click anim, here's where we actually launch the animations. So here we're going to set up if we hadn't run the full anticipation animation yet, we're going to hurry up and finish that one up before we actually launch the moving animation. Then we're going to move the thing across the screen. This is going to animate translation X property on the view. from wherever it is on the left or the right to the other side of the screen. We're going to set an interpolator of a linear interpolator. This is an interpolator that I defined above. This is an important point. I would never use linear interpolation on a movement because it looks totally fake. Instead, people, things in our real world accelerate into motion and decelerate out of it. And that's a very natural feeling motion for user interfaces as well. However, in this particular case, the effect that I wanted was for the anticipation to be the sort of accelerating into this, and then I want the motion to start immediately. When you unpress the button, I want that button to start immediately and move very quickly across the screen, and I want it to very quickly stop on the other side of the screen, because that's where I wanted the follow-through motion of the button actually overshooting where it was and then wobbling back to the start. So interpolating linearly is totally appropriate here because we're basically accelerating into it with the anticipation and we're decelerating out of it with the overshoot animation on the other side of it. So linear animation, unusually for a movement. And then we want to define the animation for the other side of the screen. So it's skewed over to the left. What we want is when it reaches the right-hand side of the screen, we want it to skew back over to the right, but overshoot. And then we want it to wobble back to where it was before. So this is the skew animation to go to the other side. And we're going to do a quick decelerator. So I wanted to very quickly slow down from the speed that it had from the linear linear interpolator that it had before in the previous animation. And then I want it to wobble. And the wobble is going to, again, animate the skew property. And it's going to use this overshoot interpolator, which will end up at the final value, but it'll overshoot it first. So that's exactly the effect I wanted. Is we've overshot to the right, and now I want it to wobble back past the stopping point and then eventually end up at the stopping point. We use an animator set to do these things sequentially, so we're going to play all the animations in sequence. We're going to move the button, skew past for the overshoot, and then wobble back to the starting position, the normal position for the button. And then we're going to play it. And that is it. Thanks.